So now let's see how we can separate two liquids mixed together. Now there's two possibilities that can arise when we have a mixture of liquids. The first possibility is that the liquids do not dissolve. When the liquids do not dissolve, for example, you have oil and water, they are said to be immiscible. They do not dissolve with each other. Now, immiscible liquids can be separated by an equipment known as a separating funnel. So this is what a separating funnel looks like. So it has a cap. From the top, you're going to add your liquid, your mixture of liquids, and then you will have a tap at the bottom here. So this is a tap, so you can turn to open, allow the liquid to flow, and turn again to close the tap. Now you put the mixture of liquid over here, you allow it to settle. After some time, it's going to separate into layers. So this is how it may look like once it has separated into layers. So here you have a mixture of a blue solution and oil. So because oil is less dense, so the oil is going to float. Whatever is less dense will be on top, will be the top layer. And whatever liquid is denser will be at the bottom. Then you can open the tap. As you open the tap, so you turn the tap, and it's going to allow the denser liquid to flow. So you can then, in a little beaker, collect all the liquid. And then as soon as you see that you are reaching that borderline with the less dense liquid, you can just close the tap. So you are able to separate a less dense from a denser liquid. So this is as far as immiscible liquids are concerned. They do not dissolve with each other. Now, when liquids mix together completely, these are known as miscible liquids. Now, when liquids are miscible, then we use something known as fractional distillation. Fractional distillation is a method that uses the difference in boiling points of the liquids to separate them. So you have two different liquids in the mixture here in the round bottom flask, and again we are going to put the boiling stones to prevent excessive bubbling. We have the Bunsen burner at the bottom that is going to heat the mixture. And one additional equipment that is present in fractional distillation but not present in simple distillation is this structure. This is known as a fractionating column. It is present only when you do fractional distillation. Now, what does the fractionating column do? It contains either beads or it contains blades. So these are either metal blades or sometimes it contains beads. Now, the fractionating column, this is going to allow the gases, the different gases that make up the liquid. So you have a liquid, let's say, consisting of alcohol and water, completely soluble in each other. They do not form layers. You start heating. So alcohol has a boiling point of around 79 degrees Celsius. Water has a boiling point of 100 degrees Celsius. Both are going to evaporate and both will form gases. But because alcohol has a lower boiling point, alcohol is going to form a gas first. So you have the gases of alcohol that will reach up, but the gases of water, the gas molecules of water, they're going to condense on these blades. This is why you have blades, or sometimes you have beads. So these will cause the gas having the lower boiling point to condense back into that flask. So the fractionating column allows the gases with different boiling points to be separated. So the one that has a lower boiling point will distill first. So it again forms, just like in simple distillation, it forms the gas that is going to condense inside the condenser here. And the condenser, you again have the water in at the bottom. And you also have a thermometer here. The thermometer is going to show again the temperature of the gas. Now the temperature here is very important because when it shows 79 degrees Celsius at constant 79 degrees Celsius, it means that you will have alcohol being distilled here. Once the temperature on the thermometer starts to increase, you know that you have to remove this flask over here. So you remove it, you place another empty flask, another empty receiver. Once the temperature reaches 100 degrees Celsius, means that now the water will start to distill off. So then you will have another flask containing the water. So you will have one flask that contains the alcohol and another flask that contains water. You will get the alcohol first because alcohol has the lower boiling point, right? Now, if you look at the top of the receiver here, this top of the receiver stays open, this open space, and this is going to prevent any pressure from building up in the apparatus so that there is no explosion or cracking of the glassware that occurs. So on this graph you can see number 1 is when temperature is rising, so there is no separation that is happening here. At number 2, here you have a constant temperature of 78 to 79 degrees Celsius. This is when alcohol is being collected. Once you have collected all the alcohol, you remove the receiver and you put it another empty receiver. When the temperature stays constant again at number 4, you know that you have the water that is going to be collected, or the liquid with the higher boiling point. Okay, so here at around 79 degrees Celsius, the volume of distillate increases. So you see it goes up, so volume of distillate increases at 79 degrees Celsius. From 79 to 100, you have no distillate that is collected, so volume of distillate stays constant. You have no new thing that is collected. So if there was 50 centimeter cube of alcohol collected, it will stay 50. Nothing new is collected. It stays constant. Then once temperature reaches 100 degrees Celsius, you have water that is collected. Then the distillate, volume of the distillate increases again, and then it will stay constant. Distillate is the liquid that is collected in the receiver. This is called distillate.